Today we're going to learn about 2.6, which is families of functions, and we're going to be referring to our piecewise function worksheet because it also includes 2.6. In the middle of the page is your assignment, the 1 through 10. I'm going to use the bottom half to do the notes 1 through 10, so you can use that as a reference. And then on the back sheet of the page, your assignment is on the left side, and I'll be using the right side as your notes. So let's start with the equation for our parent graph. Okay, here we have our parent function, and sometimes the variables are different depending upon the books, but we're going to use these so they're kind of similar to our assignment. So we'll start with identifying which each variable represents. Okay, A, that's the number in front of f of x, and it will stretch your graph vertically if A is greater than 1, and if A is between 0 and 1, it will compress your graph, so it looks like you're smushing it. These two values of A affect your y-coordinate. So you would multiply the A value by your y-coordinate, because anything that affects it vertically affects the y's. Then we have the reflections. If the number in front of, or if it is a negative A, that will reflect your graph about the x-axis. So your graph will actually flip over the x-axis. So that's only if A is negative. So it'll look something like this. Anytime you see negatives, so that means your y-coordinates will actually be opposite. I better put this so you won't get confused. Y-coordinates will be opposite of the original graph. Okay? And then a reflection across the x-axis, or the y-axis occurs when the negative is inside, like this. Which means now your x-coordinates are opposite. Okay? And then that number, the h, that affects your graph horizontally. So that's only for the part, I'm only going to write that part. The part that's inside the parentheses, this affects it horizontally. So if you see a minus, we're actually going to shift right. And whatever h is, that tells you how many units to shift. And if you see a positive, which means there were two negatives that made it positive, we're going to shift left. And h again will tell you how many units to move left or right. And then the last one is the vertical shift. I'll just write all of it. A, F, X minus H plus K. And then I'll do this one. It's minus K. Okay, the K value shifts your graph up or down. And it's not opposite. So if it's plus, you're going to shift up. And if it's minus, you're going to shift your graph. down. So the only one that shifts opposite is the horizontal. So just remember. And that's only because in the original function equation, h is already minus. All right, so let's pull out, I'm going to try to duplicate that graph so you can understand what's going on. Okay, we're on the front of your worksheet, and I'm just going to work those 10 problems at the bottom. So there says, suppose the graph of f is given. Describe how the graph of each function can be obtained from the graph of f. So basically, we're going to describe the translations for each one. So for number 1, if you notice, it says f of x minus 5. Minus 5. Okay, so all you have to do when they say describe it is just describe how it changed, and see the minus 5. Remember, that's going to be a horizontal shift, so you'll just say shift 5 units right. And that's all you have to do. And then remember, if it's plus now, that'll be negative. Or it'll be a positive inside. All right, number 2. This one is going to shift let's see if you can do it without me. Go ahead and give your guess. So if you said shift 7 units up, then you are correct. Because remember, K doesn't change. And then number 3, we have f of x plus 1/2. That's also a vertical shift, so you should say shift 1/2 units up. And then number 4, there's that negative. And I forgot mine. Now the negative is on the inside. And let me go here because I want it to look just like our equations. So I'm just going to go and change this. So this one, since the negative is on it, and whenever you see a negative, you know it is a reflection. We just have to say which reflection. So remember, this is a reflection over the y-axis, which means your x coordinates are changing, so they're opposite. And then we have number 5. If you notice on number 5, we have 2 things going on, and I always go left to right. So you see the negative, then you see the 1/2. So when we describe it, we go left to right. So we know we have a reflection, and then you have to indicate which axis. Since it's in front, it's the x-axis, which means your y values are changing because that's vertically. And we have a 1/2. Remember, that's A. So that means that is a vertical compression. because 1/2 is between 0 and 1. And then number 6, we have a 3 in front. And then we have that -5 on the end. So that's also 2 transformations. So we have a vertical stretch this time because 3 is greater than 1. And we have a vertical shift. So we could just say shifts 5 units, which way? Down. Good job. Remember, K is an opposite, so whatever it says, that's what it does. Then number 7. All right, number 7, we got 2 things going on. We have a number inside, and if you notice now, it's plus. Remember, this affects it horizontally. So we have a horizontal shift. And remember, horizontal shifts. So we could say shift 4 units left because they shift opposite. And we have a vertical shift. So we say shifts 3/4 units down. And then finally number 8. Now number 8 has 3 shifts or 3 transformations. We have the 2 in front. We have the -2 inside. And we have that +2 on the end. So we have a vertical vertical stretch. Oh, on the vertical stretches and compressions, let's write it like vertical stretch of 2 or by 2. Then we'll say it shifts. There's that horizontal. Shifts 2 units right. And then we can say shifts 2 units up. All right, let me go back up to where here, vertical shift of, or stretch of 3. Or vertical stretch by 3. And then this one was a vertical compression of 1/2 or by 1/2. And then I think that was all of it. All right, so I'm going to stretch this out so you can see all the answers. And that's 1 through 8. Okay? And make sure you look at it so you can see. So I was trying to do them one by one. And if you have any questions, make sure you write those down. Okay, this is number 9. It says the graph of F and G are given. Okay, so this is F. That's the pink. And G is the blue. And find a formula for the function of G. So right now, the first graph is f of x equals x squared, which is a parabola. And if you notice, we have to figure out, did it move left, right, up, or down. So if you notice, the pink graph moved to the blue graph, and it was at 0, the vertex, and you count it over. 1, 2, 3, 4 units right. So we have to make a new function that shows we move 4 units right. This is a horizontal shift. So remember, horizontal shifts go inside the parentheses. This one doesn't have any parentheses, so we're going to create it with the square still on the outside. And since we had to move right, you know it's minus 4. So that would be your equation for moving right. So if it doesn't have parentheses, that means that it was originally, you could rewrite it so it looks like this. And that can happen with parentheses, absolute values, or even square roots. So if it's not there, you have to actually spread it out so you can put the number there. Okay, here's number 10. Now number 10 says the graphs of f and g are given. Find a formula for g. So I'm going to make f the pink one, and g is the blue one. So for the pink graph, we have this function, f of x equals the square root of x. Now for the blue, if you notice, it moved 2 to the left, and it did a reflection, because if it only moved 2 to the left, it would have looked like this. But now look, these 2 points reflected over the x-axis. So remember, if it reflects over the x-axis, we need a negative because it reflects, and the negative has to go in front. So we have 2 things going on. So let's go left to right. So we need a negative to show that it reflected over the x-axis. And then if it moved 2 units to the left, it's horizontal. So that goes under the radical. And remember, it's opposite. Because originally, probably would have looked like x minus a negative 2 to show that it went left. And you know 2 negatives make a positive. So now, those 10 examples will help you do the middle part of your page. Now let's go to the back. Okay, it says the graph of f is given. So this is the graph that we're going to use. And they want us to sketch the graphs of all of the following functions. There are 2 graphs provided, so that, and I think there are 1, 2, 3, 4, 5, 6. So I'm going to put the first 3 on the first graph and the second 3 on the next graph. And you can do the same for your assignment, because when you do them all on one graph, it kind of gets confusing. And I'm going to use different colors for mine. Alright, so let's start. I'll just start with a new sheet. Okay, so I'm going to use black first. And this will be letter A. Right there. Okay, so A was y equals f x minus 2, which means we have to take our graph and shift it right to. All the points get shifted right to. So I'm going to start with this one. 1, 2. 1, 2. 1, 2. 1, 2. And if you notice, 1, 2, 3, 4, we started with 4, and we're going to end with 4. And there you have it. That's A. And then I'll do B in blue. Y equals f of x minus 2. Now notice the 2 minus 2 is on the outside, so that's a vertical shift, and we're going to go down 2. 1, 2. 1, 2. 1. Oops. Wrong one. 1, 2. I'm doing the original one now. 1, 2. Oh, this one I did wrong too. See, it's kind of confusing if you're going to use or do more than one graph on each one. And then, let's get a different color. We'll do green. C is y equals 2 times f of x. That's a vertical stretch. So all your y coordinates get multiplied by 2. Well, this y coordinate is at 0, so this one doesn't change. This y coordinate is at 1, 2, 3, 4. So multiplying 4 by 2, you get 8. 5, 6, 7, 8. This y coordinate is at positive 1. 1 times 2 is 2. And this y coordinate is at 2. 2 times 2 is 4. So if you notice, our graph was stretched by a factor of 2. All right, and that's the first 3. I'm going to do the second 3 on the next page. Okay, so now we're on D. Y equals negative f of x plus 3. Okay, this one has 2 things going on. We have a reflection, and the negative is on the outside. So remember, this reflects over the x-axis, so all my y coordinates change. This one is on the y. 1, 2, 3, 4. This one has to flip to 1, 2, 3, negative 4. This one flips to negative 1, and this one flips to negative 2. So basically, your graph will be upside down. And now, I have to take those 4 points and move them up 3. 1, 2, 3. So what I'm going to do is erase the original so I won't get confused. 1, 2, 3. And 1, 2, 3. 1, 2, 3. So my final graph will look like this. Upside down and shift it up 3. And then when you get good, you can you'll be able to do everything and go straight to the final graph. But until then, sorry about that bell. All right, the next one I'm going to do in blue. And look now, the negative is inside, which means we're going to reflect over the y-axis, which means my x-coordinates change. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. Oh, I'm too high. So this one will reflect over here. This one won't change because it's on the y. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it looks like that. And then the last one, y equals 1/2 f of x minus 1. This one has a vertical compression of 1/2. So all my y coordinates get cut in half. And we have to move it right 1. So this y coordinate won't change. This y coordinate, 1, 2, 3, 4 is at 4. So I'm going to compress it to 2. So you can actually see it being compressed. This one's at 1, so I'm going to compress it to 1/2. This one's at 2, so I'm going to compress it to 1. And then I'm going to shift those points right 1. Right 1, and I erase that one. Right one, and I erase this one. Right one, and I erase this one. And right one, and then I erase this a little bit, yes. And there's my compressed graph shifted right one. And now you can use those 6 examples to do the left side, which will be your assignment in class. And we are done.